morning, student. My name is NV Krishna Rao, Assistant Professor CSC Department. I am handling the compiler design subchapter for the 5th semester. In the last class, we have discussed the compiler, interpreter, phases of a compiler, right? So now we'll discuss the next continuation topics. So now we'll start discussing the regular expressions and finite automata. The language constructs all lexical rules were represented with the form of regular expressions, then convert to the finite automata, then it is converted to the machine level form and intermediate code forms. So we'll see one by one. So specification of the tokens. The lexical analysis main task is reading the source program character by character and construct the tokens. The tokens might be identifiers, operators, constant, and keywords. This specification of tokens, we use the regular expressions. These regular expressions will generate the regular languages. So, what is a language? A set of strings. String is nothing but a set of alphabets, right? We already discussed what is a lexical analyzer, the first phase of the compiler. Its main task is read the input character by character and delete unwanted spaces, comments, and simply generating a sequence of tokens. The sequence of tokens is output of the lexical analyzer. How it will generate the sequence of tokens? By using the lexical rules of the source language. The lexical rules of the source languages are represented by irregular expressions. A pattern is represented by regular expressions. These regular expressions will generate the regular language. What is a language? A group of strings. The smallest undivisible entity is symbol. A group of symbols, alphabet. A group of sequence of symbols from some alphabet is string. A group of string is language. Right? So the languages are represented by regular languages if they are accepted by regular expressions. Right? So here symbols, a group of symbols is alphabet and a sequence of symbols from the alphabets is a strings. A group of strings is a language. We represent the languages with the regular expressions. Then we say the language is regular languages. Then we discuss the operations on the strings and languages and how to write the regular expressions, regular definitions. Right? We'll discuss these topics one by one. What is a symbol? Symbol is a single undivisible object, an entity. Right? Symbol is any single object, undivisible. It is the smallest entity. So zeros, 1, 2s, ABC, all are symbols. So here we can simply say 0 to 9, A to Z. All these are different symbols, right? The smallest entity which further cannot be divided. A finite set of symbols we call as alphabet. So what is an alphabet? A finite set of symbols. A finite set of symbols we call as alphabet. Right? So we represent alphabet with this notation, tau or sigma. These are the notations for the alphabet representation. So here in the first example, the alphabet has only two symbols, that is 0 and 1. In the second example, it has all the lower cases A to Z as the alphabet. right? So it should not contain Latin letters. So alphabet is a finite set of symbols. So in the first example, 0, 1 is the symbols, right, of the alphabet, only the two symbols. Here in the second example, the letters, small letters A to Z, the lowercase symbols are the symbols of the alphabet, right? Then what is a string? String is a concatenated symbols from the alphabet. A string always constructed on some alphabet, right? So generally we use the symbols U, V, W, X, Y, Z to denote the strings. So a finite sequence of concatenated symbols from some alphabet we call as a string, right? No parentheses or commas are used. We'll see the examples. So here these four zeros is a string over the binary alphabet. So what is a binary alphabet? Zeros and ones. So it is a string consists the four zeros from the alphabet 0 and 1. Here it is a alphabet A comma B. Here our alphabet A comma B. Then this is the example strings. A also a string having one character, one symbol from the alphabet. B also a string having one character, one symbol from the alphabet. Then AABB is a string of 5 symbols are constructed from the alphabet A comma B. Then here our alphabet is 0 and 1. Our alphabet is 0, 1, and example strings are only 0, 1, 0, 0, 0, 1. It is a string of symbols. It is a string of symbols from some alphabet. Right? Then a null string is a string with no symbols. It is denoted by epsilon. Right? It is denoted by epsilon. Lambda. An empty string means a string with no symbols. It is represented by epsilon or lambda. Then length of string. What is the length of a string? The number of symbols in a string is called the length of the string. The number of symbols in a string is called the length of string. We represent the length of string is mod of W. W is a string, then length of string is represented by mod of W. It can be empty string. It has no symbols. Then its length will be 0. Right? It can be empty string. The length of empty string is 0. Also called a null string. It has no symbols. Means what is the length of null empty string? Null string. It's simply 0. For example, in this one, how many symbols are there? There are 5 symbols. Right? 0, 0, 1, 0, 0. So it is a 5 symbols. Right? Then in this example, there are 3 symbols. A, B. Right? There are 3 symbols. Then what is the length of empty string? Empty string length is always 0. Length of epsilon is always 0. Small case letters towards the beginning of an English alphabet to denote the symbols of an alphabet. So here we are considering the ABC. Small case letters towards end denotes alphabet U, V, X, Y, Z are the strings. So depending we use small case letters for the beginning of the English and end of the English alphabet. Right? Then what is a language? A set of strings over some alphabet is called a language. right? We represent language as capital L, right? What is a language? Is a set of strings. The strings are constructed from the symbols on some alphabet. What is alphabet? A group of undivisible symbols, right? A concatenated symbols from alphabet we refer as string. A set of strings as language. So, which is a set of formation rules that describe which strings formed from alphabet or formal language are syntactically valid. Now, here this is an infinite language over the binary alphabet. Here it is a finite language. Second example is finite. What are the strings it has? This language has three strings A, B, B, A. Here, this language is infinite length because it's constructed from zeros, any number of zeros, 0, 2 zeros, 3 zeros, and so on. We are representing as it is an infinite language. The second example is a finite language of three strings. The strings are constructed over an alphabet A, comma B, right? Then the membership problem. Given a string X, whether X belongs to L or not, that we say as the membership problem. The given string will belongs to from our respective language or not, we specify as X belongs to L as a membership problem. Used for precise definition of data formats and the syntax of the programming language, right? So here these regular expressions, regular languages, the context-free grammars, context-sensitive languages, or recursive languages, all these are important in developing the compilers, right? The a language that is accepted by regular expression we say as regular language. So the language accepted by context-free grammars, context-free language. These are used to represent syntax rules, lexical rules for regular languages, syntax rules for the from the context-free language, and also we use context-sensitive languages, languages, recursive enumerable languages that are used for the development of the compiler, right? So, formal language theory uses separate formalisms, automata to describe the recognizers, right? So, we discuss the recognition of the languages, right? Now, we'll see one by one. A set of strings, O of zeros and ones with no consecutive ones. Here, what is a alphabet? Alphabet is zeros and ones. It is a alphabet is zeros and ones. Then, what is a language? It is a set of strings with no two consecutive ones. So this is a infinite language. It has all the strings which doesn't contain two consecutive ones. It doesn't contain two consecutive ones, right? Then our second example is palindromes. What is a palindrome? When you reverse a string, we will get the same string. Then we say the string is palindrome. Here, what is the alphabet? 0 and 1 is the alphabet. Then this is the different strings example for the palindromes. L is a language which consists the palindromes as the strings. So these strings when you reverse also will be the same strings. 0 1 0 reverse you will get the same 0 1 0. 1 0 1 if you reverse you will get the same 1 0 1. 3 zeros. If we reverse, we'll get the same 3 zeros. 0, 0, 1, 1, 0, 1, epsilon. All these are examples for the paragraphs. Right? So the language of all strings consists of zeros followed by ands are given by as this one. So what is the language here? What is the description for the language? It consists from alphabet 0 and 1. What is the construction? Zeros followed by ones. Right? N zeros followed by n ones. Equal number of zeros followed by ones. So that is the language description. So 1 0, so there is a 1 1. 2 zeros, so it is followed by 2 ones. 3 zeros, so it is followed by 3 ones. Right? So here it is a language of all strings consists of n zeros followed by n ones. Right? So programming language C. Illegal programs are a subset of the possible strings that can be formed from alphabet of the language. So for every language there is a character set, alphabet. From that alphabet we construct the programming statements. Right? Next example, fifth one. Equal number of zeros and ones. It is constructed from a alphabet of zeros and ones, but it consists equal number of zeros and ones in any order. 0 1 0, 1 0, 2 zeros, 2 ones, 0 1 0 1, 1 0 0 1. But in a string there is equal number of zeros and ones. Right? So all possible Java keywords, all possible lexemes corresponding to Java tokens, and all possible lexemes corresponding to Java whitespace. So this is for the example for the Java language. Right? We are considering a Java Unicode character set. Right? From that one we can construct all the Java keywords, all the Java tokens and white spaces. So what is empty language? The empty language is represented by 5. So this is a notation for the empty language. Right? It is the notation for the empty language. Right? Here it is a language which consists the empty string. Right? Here when you observe, these both are not the same. It has empty language, means there are no strings in the language, but it has a language with empty string. It is a language with empty string. It is no strings. Right? That is the difference between 5 and a set of epsilon. Right? So here basic definitions. A grammar generates a language that is recognized or accepted by some machine. Right? A grammar generates a language. What is a language? A string, a set of strings. The strings are generated from a grammar. Right? Regular grammars, a context-free grammars, like that. These languages will be accepted by some machines. If it is a regular grammars, accepted by finite automata. If it is a context-free grammars, accepted by push-down automata. Right? Now we'll see string operations. The first one is concatenation. Right? The first one is concatenation. So here, this is a first string. This is a second string. Concatenation of the U followed by V. What is the order? U followed by V. So first U characters, then V characters. The concatenation of symbols of U followed by symbols of V. Right? Symbols of U followed by symbols of Then, what is the next one? V followed by U. The concatenation of V followed by U means symbols of V followed by symbols of U. Right? What is the concatenation? Is a group of symbols of U followed by V symbol. VU means symbols of V followed by symbols of U. What is a prefix? Prefix is a group of leading symbols or starting symbols of any string. It's a group of leading symbols or starting symbols are referred as prefix of a string. U is a prefix of V if there is a W such that V equal to UX. Right? Now, what is the here? 101. First of all, empty string is a valid prefix. Empty string is a valid prefix. Right? Is a valid prefix for a given string. Then 1 is a preceded the initial leading character. So 1. Then another leading characters 1 0. Then 1 0 1. A group of a sequence of leading characters, starting characters, we refer as prefixes of V. It will refer as prefixes of V. V is a prefix, then epsilon 1, 1 0, 1 0 1 are the valid prefixes. Right? What is a suffix? A suffix is a group of symbols and symbols. Tail symbols. A group of tail symbols and symbols we refer as suffix of a given string. U is a suffix of V if there is a W such that is VWU. Right? A group of end symbols, tail symbols are referred as suffix of the given string. So, if we consider 101, epsilon is the valid suffix. Empty string is a valid suffix. It might be 1, it might be 01, it might be 101. Right? So, either 1, 01, 101. A group of end symbols, tail symbols, we refer as suffix. Next, substring. A substring is U is a substring of V if there is X and Y such that V equal to X U V. Right? Here V equal to 101, then epsilon 0, 1, 1 0, 0 1, 1 0 1 all are the substrings of V. It can be obtained by removing 0 or more leading symbols and removing 0 or more AND symbols are both leading and AND symbols to get a substrings of a given string. Right? Prefix and suffix are special cases of substrings. Right? Listen here. The substrings are obtained by removing 0 or more leading symbols or 0 or more AND symbols or removing both from leading and AND symbols to get a substring of a given string. Right? Here, if we consider 0 is a substring, but it cannot be a suffix or prefixes. But all suffixes and prefixes are the substrings of the given string. Right? So next comes to the proper prefix and proper suffix. Proper prefix means is a list of all the prefixes other than given string. Other than given string. A prefix cannot be same as the given string. Then we say it is as proper prefixes. A prefix should not be same as given string. Then we say it is a proper prefix. Other than all the prefixes, other than the given string, we say as proper prefixes. Right? So, next, proper suffixes. All the suffixes other than the given string are say as proper suffixes. A suffix should not be same as given string. Then we say it is the proper suffixes. All the suffixes of a given string and you should not same as given string. Then we say all the suffixes as proper suffixes. So if we consider 101, in the previous we have seen epsilon 110. And 101 is a prefix, a valid prefix, but not proper prefixes. Suffixes, if you consider suffixes, epsilon 101, right? Epsilon 101. These are the proper suffixes. But another suffix, 101 also a suffix, but it's as same as the given string. So it is not the proper suffixes. Right? Is it clear? Then string operations. Power of a string. Right? Here, if string x equal to 0.11, then x power 0 means length 0 means epsilon. Right? Here, for any string x and integer n, we can say x power n is the string formed by concatenating n copies of x. Concatenating n copies of x. X power 0 means of length 0. So, empty string. X power 1, so given string. X power 2, x followed by x. Concatenating n copies of x. So, 2 copies of x. So, first x, second x, third x. 3 copies of given string x. Right? Power of alphabet. X power k. K is an integer. Then denote the set of strings with length k with symbols from the alphabet. Right? So, the length of w will be k. The length of w will be k. Right? Empty strings of length 1, of length 2, of length 3, all these are having length 3. So, power of alphabet, right? Power 3 means it consists the all the strings having length 3. Right? Then, star alphabet. Right? A set of string, all the strings over of alphabet represented denoted by as star alphabet. Star alphabet, it is a union of all the strings of lengths 0 to k. Right? Or 0 to infinity. Right? If alphabet is 0 and 1, e power 1 contains a strings having length 1. Right? Kleene star are closure of alphabet. Right? Just now we discussed star closure of. Kleene star are closure of the alphabet. It is a set of all the strings of length 0, 1, 2 and so on. Right? If it is a alphabet is A comma B, then star alphabet, a close of the alphabet, is the strings that are constructed of any length from 0 to infinity from the symbols A comma AB or BA, 3As, AB, BA, ABB or BA, or if it is of any length of string constructed from of any length of characters from the symbols of the alphabet of any length. If it is an empty set, empty language, then it will be this one. Here is infinitely many words, each of finite length. Then another one is positive closure. Right? Another one is positive closure. Positive closure of an alphabet, star closure of alphabet minus epsilon, means it will consist a language of length 1 to infinity. Length from 1 to infinity, then we say it has positive closure of alphabet. Right? So is it clear? Removing this empty string, null string, no, is results to the positive closure of alphabet. Right? It consists the all the lengths of 1, 2 and so on. Right? Then basic operations on the languages. Right? So here the basic operations, union, intersections and differences. Now we'll see one by one. Here it is a language union with this one will results to this union, all combined. Right? Right? It's containing BB and AB. All these are available. All strings are combined from the both languages to this one. Intersection, a common one, that is AB and AB. Only AB is a intersection. This one minus this one, right? So remove this one, just to A comma 4s. A minus B. So the B strings are removed from A will result the A minus B. Next, complement. Language L subtracted from the star closure of alphabet. Subtracted from the star closure of alphabet. Right? So here, what is the star closure of alphabet? It consists the all the strings of lengths from 0 to infinity. So this A comma BA complement from this star closure minus A comma minus BA. Except these two, all the strings will be in the complement of A comma BA. Just we are removing the two strings A comma BA will result to the complement of the language L. Right? Star closure of alphabet minus L will result to the complement of language L. Reverse. AB as written as BA. Right? AB as BA. BA as AB. AB. A power n, B power n as B power n, A power n. Reverse of the strings. Then concatenation. X belongs to L1, Y belongs to L2. Concatenation of X and Y means A followed by B, A followed by 2A's. So which results to AB comma A. A and A belongs to L1. This B and 2s belongs to L2. Right? The first characters are belongs to language L1. The second characters will belongs to language 2. Right? So concatenation of L1 followed by L2 means the strings of L1 followed by strings of L2 will be the concatenation of the languages. Then star close of a language. Star close of a language L star is all the union of the strings L power 0, L power 1, L power 2 and so on. L power 0 means given string. L1 empty set. L power 0 means empty set. L power 1 means given language. L power 2 concatenation of L and L. L power 3 means concatenation of L followed by L square and so on. Right? So here epsilon, this is L, this is L followed by L, this is L followed by L square and it will be goes on. Right? Is it clear? A, B, B is a given string. A's followed by B's. Right? Then here A followed by belongs to L square. A followed by belongs to L square. A concatenation of L followed by L, concatenation of L followed by L square, concatenation of L followed by L cube and so on. So 0, 1 is a language, L star is all strings of length 0 and 1. Right? So it might be epsilon 0, 1, 0, 0, 1, 0, 0, 1, 0 and so on. 0, 1, 1 is a given language. It consists all the strings of zeros 1 such that 1 come in pairs. 1 should be in pairs. Right? 2 ones, 2 ones, 2 ones. But here 2 ones, it is not. It is not pairs. Here it is a language such that 1 come in pairs. So this is valid. These both are valid. But here it is invalid. These are invalid. Right? Then positive closure. L star means minus empty set is gives to the positive closure of language. It gives the positive closure of language. Right? So it is a given L. This is a L concatenation with L. This is L concatenation with L square and so on. It removes the empty language. It removes the empty language. Right? So language is a group of alphabet. From the alphabet, it's a string. From the strings, we using the grammars and we construct the languages and its operations. So what are the operations? Operations and languages: concatenation, union, intersection and star closure. So in this class, we are discussing the basic concepts of the finite automata: strings, alphabets, operations on the strings, operations on the languages. So I am closing this section with this basic concepts. So we'll continue the remaining topics in the next class. Okay?
Like, share and subscribe. Hit the bell icon for more updates.